Hi friends, welcome back to our channel Easy Mathematics. In last video we discussed about functions, isn't it? Today we are going to discuss a special type of function. We have different types of function. Today we are going to discuss one function in detail. So when a function from a set to another set become a one function, and how we can verify whether the given function is a one function or not, then total how many number of one functions we can define from a set to another set. So in this video we are going to discuss one function in detail. One function, it is also known as injective function. So a function f from a to b, when we can say this function f is a one function or an injective function. So what is the condition to be satisfied by a one function? So we know if f is a function from a to b, first set A is called a domain of the function, second set B is called a codomain of the function, and codomain range of the function is always a subset of codomain, isn't it? Range means set of all images. Image set is known as a range. So range is always a subset of codomain, that we know. Then if f is a function from a to b, when we can say f as a one function, one function is this: different elements in domain should have different images. So if you choose two different elements from domain, so here it is A, so you choose two different elements from A domain. If it has two different images in B, then we can say this function is one. So that condition should satisfy for all elements in domain. So if you select any two elements from domain, if they have two different images, different elements from domain must have different images, then such a functions are called one function or injective function. So how we can denote it using arrow diagram? Suppose A is this, B is this, f is a function from A to B. Then if f contains x1, x2, x3, y1, y2, suppose y1, y2, then I am defining a mapping like this. So we know by the definition of function it satisfies, isn't it? It meets the definition of function. So this mapping is a function that we know because every elements in domain has unique images. x1 has only one image, that is y1. x2 has only one image, that is y2. x3 has one image, that is y1. So this mapping is a function. So this mapping is a function. Then is it a one function? That is what we want to check, isn't it? So how we want to check? We choose any two different elements from domain. Suppose I am selecting x1 and x2. They are two different elements from domain A. Then what about their images? That also we want to check. So x1 has image y1, x2 has image y2. So x1 and x2 are two different elements from domain. They have two different images. So it satisfies. But what we want to check, is it satisfies every element from domain, isn't it? We want to check this condition for every elements in domain. So what about x2 and x3? They have two different images. x2 has image y2, x3 has image y1, isn't it? So x1, x2 satisfies, x2, x3 also satisfies. But if we are selecting x1 and x3, what about this condition? x1 has image y1, x3 has image y1. So x1 and x3 are two different elements from domain, but they have same image y1. So Two different elements from domain have same image. They have same image. So this function is not a one-one function. Suppose instead of this, suppose I am adding y3, then I am mapping x3 to y3. Then here this function, now it becomes a one-one function. From this example we can generalize one more important point. Did you notice it? Yes. What is that condition? To define one-one function, number of elements in codomain should be greater than or equal to number of elements in domain. So very important one condition to define a one-one function. So to define a one-one function, number of elements in codomain should be greater than or equal to number of elements in domain. So n of b should be greater than or equal to n of a if we are defining a function from a to b. So number of elements in b is greater than or equal to number of elements in a, then only we can define a one-one function. Clear? So very important one condition for defining one-one function. So to check whether the given function is one-one or not, we have a procedure. That procedure is like this. F of x1 is equal to f of x2. So we start with f of x1 is equal to f of x2. If we are able to prove x1 is equal to x2, then we can say the given function is a one-one function. So what is procedure for checking one-one function? F of x1 is equal to f of x2. Start with this statement. From the statement, if we are able to prove x1 is equal to x2, so images are equal. So f of x1 is equal to f of x2 implies, what is meaning of that statement? Meaning is x1 has image f of x1, x2 has image f of x2. So two images are equal, then corresponding pre-images are equal. So images, if images are equal, then pre-images are equal. Then one more procedure is there, that is this one. x1 not equal to x2. x1 not equal to x2. If we are able to prove f of x1 is not equal to f of x2, then also we can say the given function is a one-one function. So we have two procedures for verifying whether the given function is one-one or not. So this is first one, f of x1 is equal to f of x2 implies x1 is equal to x2, or x1 not equal to x2. Domain elements, pre-images are not equal, then images are not equal. So these are the two methods to verify whether the given function is one-one or not. So last very important one point that we want to discuss is number of one-one function. Suppose f be a function from a to b. F be a function from a to b. How many one-one functions that we can define from a to b? So that is a very important one more question. So in JEE main point of view also, this is a very important one point. So f is a function from a to b. How many one-one functions we can define from a to b? Let n of a is equal to m, n of b is equal to n. So n of a, that term we are familiar with, isn't it? N of a means cardinality of a, isn't it? Number of elements in a. So a contains m elements, b contains n elements. Suppose if a contains m elements, b contains n elements, then how many one-one functions that we can define from a to b? So formula is this. So number of one-one function is equal to npm, where n is greater than or equal to m. So this is the formula for finding number of 1 function, NPM. So we are familiar with this P, isn't it? In class 11, we have one chapter, permutations and combinations. So this P stands for permutation. So NPM. So this is applicable only if n is greater than or equal to m. So this is the condition that we discussed in the first section, isn't it? So n is greater than or equal to m means number of elements in codomain is greater than or equal to number of elements in domain. Then only we can define one functions. So total number of one function formula, total number of one function is equal to NPM. NPM. So we want to discuss one example how we check one condition. For that purpose, let f be a function from real number to real number. So f is a real valued function and f of x is defined like this. F of x is equal to 2x plus 1. So we are going to check whether this given function is 1 or not. So we have two verification methods. So first verification method I am going to apply. Then we want to check how we apply and how we prove. So in first method we want to start with the f of x1 is equal to f of x2. So f of x1 is equal to f of x2. If we are able to prove x1 is equal to x2, proved, isn't it? So f of x1 is equal to f of x2. I am starting with f of x1 is equal to f of x2. So I am replacing f of x1 with the given definition. So f of x is 2x plus 1. Then f of x1 will be 2x1 plus 1. So here in the place of x I am replacing x with the x1, that's all. So here f of x2, how we can write 2x2 plus 1. From both sides what we can cancel? Plus 1 is there, so that we can cancel. So next step, 2x1 is equal to 2x2, isn't it? So we get 2x1 is equal to 2x2. From this step what we can cancel? 2 we can cancel. Then we get x1 is equal to x2. So we started from f of x1 is equal to f of x2. Then we are able to prove x1 is equal to x2. So what we can assume? The given function f of x is equal to 2x plus 1 is a 1 function. So this is how we verify whether the given function is 1 or not. If you are new to this channel, don't forget to subscribe and click the bell button.